Good morning. Just testing the audio before we get started. Welcome, everybody. Welcome to another session of Microcontrollers with kingernorth. This is episode 7, connecting a LCD display with CircuitPython and Arduino. So let's have a look at what we're going to be using today. So just before we get too involved here, I just want to start showing you there's lots of different displays out there that are available to us. Some of these are LCD displays, some of these are not. So basically, these ones at the top here, these are all LCD displays. And they're of varying sizes. This is the standard that most people see, and this is 16 characters across and 2 rows of text. Then we get into a little bit larger screen. This has got 16 characters across with 4 rows of text. And then this is the largest one that we normally see, and this is 20 characters across with 4 lines of text. These are all basic displays. They all work the same other than you choose the size of your screen. So they're pretty easy to work with. Then there's lots of other options out there. There's little what they call OLEDs, which you're starting to see in TV technology with OLEDs. OLEDs are a low power. They have no backlight. They are lit LEDs. So they're organic LEDs. This is one that's done in a feather format. So this fits onto my feather boards like my Feather M4 that I use for programming here. This is another version of it here with a different resolution, different size, and a little tiny one over here. That's actually got half the size of this one, but is the same as the feather version. So these have about 128 dots across by either 32 or 64 dots down. Now they don't go by character lines because you can vary the size of the text on these OLEDs, which you cannot really do with LCDs. Then we move on up into this type of screen. This is a Tft screen. Tft is very common screens. They're used in a lot of things. Fortunately, they draw a lot of power. They have backlight, but you're talking usually full color or at least quite high resolution of color. And the resolution on these vary quite a bit. So now you can produce both graphics and you can produce text as well, and you can vary the colors as you see fit. This type of screen is what they call e-ink. The e-ink is kind of unique. This is actually showing the 3 colors and power on this thing, but it maintains an image on here. So what happens is once you put an image on here, you can turn the power off to it, and it will display for a long period of time. You may have seen that with some of the items that you've used and seen that around and that there's an image, but they're very low resolution as in colors choices, usually only 2 or 3 colors. But the image stays for a long time without anybody having to interact with it. So it'll hold the display for a much, much longer period of time. So they're very economical to run and take very low power because you only power them up when you want to change the image. Now, they don't change instantaneously like the rest of these do. These do take a couple of seconds to draw the image onto the screen. So it does it as in passing each color separately. So it takes a little bit more time. But you get the advantage of power saving in between. So if you don't need to update your screen often, this is a great choice, and it's great for low power conditions. Because you can power down put your microprocessor into sleep mode. And basically when you power it up, you do the update on the screen and then you power it back down again. So a battery can last you an awful long time when powering devices like this. And finally, we have numerical or alphanumerical displays like this one here. This is a multi-segment. They make a 7 segments per digit. A 7 segment per digit will do just numbers. Basically, it does 0 through 9 per digit. This is 4 digits wide, but this one with having all the extra little pieces 13 segments in here. You can do alphanumeric as well as some symbols. You can do arrows, you can do a few different things like that. So you can actually create some different features. But again, these drop a fair bit of power because they are LEDs that are lighting it up inside. So these are all LEDs. So LCDs require a backlight. That's the one we're going to be using today. OLEDs do not, so they are very low on power consumption, but they tend to be very small. And you're also limited. Usually, if you want to get into a large OLED screen, they get very expensive. And you can tell that with a few $100s for your TV. Most of that cost of that TV when you're buying an OLED is for the screen itself, the screen technology, not the electronics behind it. Okay, then we have TFT if you want higher resolution and multicolor. And then we get E-Ink if we want extremely low power but limited color resolution. So it's almost like having a black and white image. In fact, they make just a two color version, which is just black and white. This more with it, not as high a contrast of an image and everything else, but super low power. So those are your basic choices. So from there, we're going to move on and we're going to move into our main screen here. And I'm going to move those out of the way and I'm going to show you what we're going to be working with today. So I'm going to start by getting rid of these. So we'll just move these. There's lots of little displays here, so we're just going to move them out of the way. And I'm going to show you what we're going to be working with today. This is one of them. This is the M4. Now I'm not zoomed in yet because I'm also going to bring in this one. Let's see how this one wants to sit in the frame. We're just going to kind of fit it on the page here. And this one also has a on it right now. But these are two different screens. These are the same kind of screens that are on both of these. This one's connected to an Arduino Uno. This one is connected to a Feather M4 Express. So just two different technologies. This uses the Arduino language. This uses CircuitPython. So we're going to be working with them. One of the biggest problems we have with any of these is this screen here. And what happens with that is that these get very bright against a camera lens. So we're going to do what we can to make that look right. I'm not sure how well that's going to work, but we're going to find out. So let me just move one out of the way right now and let's get started with this. And we're going to zoom in a little bit because we don't need all that much room. And we're going to do that. So we're going to start with that. So let me talk a little bit about how these LCDs are connected, because there's a couple of different ways of doing this. And I have an image up here. I went and did some searching on the internet. So we're going to go up here and we're going to go and we're going to open up LCD wiring. On Google, I get lots of images. And there are lots and lots of choices here in what to do. And what I've done is I've opened up a couple of them. One of the ways of doing it is to do something like this. And you can actually take that and you can connect a whole bunch of wires, some to power, some to ground, some back to the board. And if you want, you can add a pot off to the side so you can adjust the contrast on the screen. And you can actually get your image working up on the LCD. Now, part of the problem with this is that when you're trying to do this, this takes up a lot of pins on your board. And you can see here there's 1, 2, 3, 4, 5, 6 wires connected, plus power and ground, that are connected back to the Arduino. And this would be the same whether you're connecting to an Arduino or to a CircuitPython board. They would require that number of pins if you wanted to run them without an interface in between. So we generally don't do this. What we use is we use it through a communication protocol. And there is a simple protocol, and it's called I2C. And this is an I2C, you'll see it listed as, or sometimes I've seen it as IIC, but it just stands for I2C. And basically what it is, it brings this down to only needing 4 wires in this connection. So again, you have a power pin, you have a ground pin, and then you have 2 communication pins, and these are called SDL and SCL. And that's basically it's an I2C data line and an I2C clock line is the way the two things work. And they talk back, and they're connected to 2 pins either here Or if you have a more modern Arduino Uno, they usually have SDA and SLC pins, SCL pins, I should say, separately up here. They also connect through A4 and A5, which is the way that most people connect them, because internally these are the same pins on the board. So it doesn't matter which ones you go into, you're still using the same pins. Different boards have different ones. On the CircuitPython board, I'll show you that. It has some dedicated pins that use it. But basically the idea is we go there through a protocol. Now the difference is, and I'll show you what the difference is that we don't just hook up to all these pins that are here anymore. We need something to go between the pins that are built into the LCD screen and the 4 wires that we're going to take off and connect to here. So let me show you how that's done. On the back of this board, I'm going to turn it over. We can actually see that I have connected on here right now. And in fact, I can unplug this one because of the way I set it up. This is an interface board. Now, this is one of many types of interface boards out there. There are more than one. So what happens in here is this is one made by Adafruit. Now, this one has the capability of working with I2C or with SPI, which is another protocol but uses 5 wires instead of 4. Both work well. I2C is the way I'm using this one right now, just so that they're both the same. But this one has the ability to be set up for 2. Now, I talked about that one picture showed a pot for the contrast. Well, on here, on the back of this, there's a little tiny pot here, and that's what adjusts your contrast on here. That can be sometimes the most finicky thing about the LCD. You don't know whether it's working or not, and you have to play with that and pull an image up on the screen so that you can see it and you can make that adjustment. So we're going to do that and see if I need to adjust it or not when I plug it into my board. When you look at your LCD, all I've done is I've connected soldered a bunch of pins on, and that just connects to those top of the row pins on top of the LCD. Now, there's 16 pins typically along most of these. Some of them have more, some have less. But typically these are 16, so you have to be careful when you're buying your LCD. It should come with all 16 of those, and then they'll connect to one of these boards. Now, there are aftermarket boards that work with this as well, and I have one on the back of the other board that I'm using, and we'll show you that one later when we bring it over. It's just a version that came off of eBay. It's definitely cheaper cost-wise, but it doesn't work well with the CircuitPython, but it does work fine with Arduino. So let me plug this back together first. There we are. I have it set up so it's plugged in, so it makes it easy for me to work with. And let me just bring those into the wires here connected. I have one connected to power. Now, CircuitPython is a 3.3 volt processor. So in order to help it out, I plug into the USB pin because the USB has 5 volts. LCDs typically like 5 volts, not 3.3. I have a ground pin connected as well, which is over here. And then I have on here, there are actually 2 pins marked SDA, SCL. And they just connect to the corresponding pins on the screen. So it makes it pretty simple. 4 wires, a lot simpler than that basic setup. So let's get started with this. I have my coding page up here. And what we're going to do is we're going to work through this, and we're going to write some basic code. So I'm going to start out with my comment up here at the top like I normally would. So this is an LCD test. Oh, actually by kingernorth. So I'm just going to put that in there, and I'm going to drop down a couple lines. Now the next thing we want to do is we want to import any files that we're going to use. And we're always going to add those helper files at the beginning. So I'm going to write import, and I'm going to use time because I want to put in some delays. I'm going to import the information, import board because I need all the board connections, all the little wiring that's going to be needed. Import bus IO because I'm going to be talking to inputs and outputs. And the last thing I'm going to do, this is an extra file that we haven't used up to this point. And this is going to be, we're going to import and we're going to import a helper file, and this is actually a file that we would drag over from our libraries that I've talked about in the past, and we would get the latest group of libraries, and we would drag over the file and put it inside the library folder on the Arduino, or pardon me, on the CircuitPython board. And this one's just called Adafruit underscore, and this one's going to be character underscore, and then it's got LCD, because we want to talk to it, and we want to bring in the subfolder from it called character. I know this looks really long, and it is, underscore LCD underscore I squared C, and then and then we got to name it something. We're going to name it underscore LCD, and just leave it at that. So that's long, but it's there. So that was a long character name. It's something that you'll find in helper files, and luckily places like the Adafruit Learn Guides have lots of information on this, as well as other people on the net. Lots of people have been doing this, so there's lots of good information. And you're going to have to set up your LCD board regardless of which language you're going to use, because they don't come with that function imported automatically. You're going to have to include a helper file, and I'll show you how we're. And there's too many choices in the real world, and we have to find the one that works. So don't be upset if it doesn't work first time. Sometimes you just have to figure it out. So the next thing we're going to do, though, is we've got to do a couple of things here. So we're going to set up this I2C protocol on the board. So I'm going to do that here, and I'm going to go I2C, and I'm just going to call it that equals. And what this is going to be, this is the bus IO, because I need to talk to the board pins. And I'm going to go dot I2C, and we're going to put in brackets, and we're going to use our board connections. So this is board, and luckily for this board, it's just called SCL is what it's been named, comma, and then we're going to connect the SDA pin. So this is going to be called board .SDA. If you don't know the name of these pins, you look them up in your information for your particular board that you're using, whether it be the Arduino or whatever. And we set it up, and we just basically have to define what pins we're going to connect the I2C bus onto. So that's what we're doing there. So all of this has gone to create so that we can create the I2C protocol. So we just created a variable called I2C, and that's where it's going to be assigned. That way we only have to type this once. If we don't make it equal to something, we're going to have to type it over and over and over again. And that's never going to work well. So let's move down to the next section. The next section is we're going to actually set up, now that we've got pins to talk to, we have to set more parameters for this LCD. Well, this particular LCD that I'm using here, this has got 16 characters across by 2 rows. So we're going to have to add those labels in here. So we're going to go LCD, and I'm just trying to match some. I've already got some pre-written text ahead of me, just to make my life easy. And in this case, we're going to say that there's 16 columns, and we're going to go LCD underscore rows, and we're going to make that equal to 2. So we're defining the size of our board. And then what we want to do is, the last thing we want to do is we actually want to create the LCD screen now by combining all of our information together. So this is what we do, is we're going to create something called LCD. We're going to say this is going to equal, and what we're going to do, this gets a little long, but that's okay. This is going to be character LCD dot, and then we're going to put in character because that's what we want to bring in the subset. And like I said, you're going to find out a lot of this information. Let's see, I'm going to make sure I spell this right. LCD underscore I2C. files. This is why you want to go out to those helper files and read an example on these. If you read the example, you'll see some of the requirements that are added. And unfortunately, we do have to have requirements to set up new devices. So we're going to call this I²C. That's the one we just created, and we created that here on rung 8. So that's that variable. We're going to add one in here called LCD_columns, and we created that. And LCD_rows, and we're going to put a bracket at the end. So my I²C is, or my LCD is equal to character LCD, character LCD, I²C, and we're going to say, here's the pins we're going to connect to. This is how many columns we're using, and this is how many rows we're using. I could just enter the numbers 16 and 2 in here and make this line a little shorter, but it doesn't really matter for what we're doing. We're just trying to get the idea in here that we can build it, and that way if I use a different size display next time, I use one maybe that's 20 characters by 4 rows, I just change these two numbers and now it works with that one. And that's really all there is to it. So everything here is what's involved in getting this one started. So after this, we're actually ready to write programming. This actually takes care of everything that we need to do ahead of time to make this work. And you're going to see in Arduino, we do it a little differently, but we still have to do it. We still have to create all of these interfaces and these connections before we get started. Otherwise, it's not going to work for us. And I'll show you how to do that. We've done this. We've done the I²C. So now we're going to jump right into while true, which is our way that we're programming in the CircuitPython world, and we're creating our language right now. And we're just going to go with a nice simple message here, and I'm just going to create it as an LCD because I've created that object called LCD. I'm going to write that big long line every time. I'm just going to use LCD, and there is a message function for it, and I'm just going to say that's going to equal, and I'm just going to put in here, let's do it that way, hello to you. Okay, and that's all I've done here, and basically that's just going to print that message. What I'm going to do is I'm going to put it on here so it puts it into a loop to show you. I'm going to put time.sleep, and we're going to give that, let's say, 5 seconds, because we're going to see how that works out for us. And then what we're going to do is after we've done that, we're going to go LCD dot, and to get rid of the message, we can use the function called clear, and that will just take all the text back off the screen that we just wrote. And we're going to let that sleep for, let's use the lowercase time.sleep. And again, we're going to give it another 5 seconds. So basically what should happen in this one here, we're just going to put up the message, hello to you. It should come in. And since I didn't give it a place to tell it to start writing, which we will when we start giving it positions, is you can actually give these things positions. But I'm just going to say hello to you. I'm going to tell it to sleep. I'm going to tell it to print that, and it's going to print it in the top left corner of the screen. And it's going to do it here, and it's going to come in. Now, the one thing that we didn't do that might cause us problems is we don't have something in here for the backlight. And it may work, it may not work. We'll test it. And I think by default it does come on. It's just I'm going to show you some extra features with that. So what I'm going to do is I'm going to click on check, that check button at the top. And when I do, it said way down here at the bottom, and it's actually off of your screen. Oh no, it's there. It's there. It said nice one. Go ahead and download this. So what I'm going to do is I am talking to this board already, and if I hit save, it's going to do it. And it put it on the screen that says hello to you right on my screen. After 5 seconds, the text disappears. 5 seconds later, the text should come back on, and it did. So we're good. So this actually worked, and the LCD lit up. Now, we may not want, so hey, we made it through the first step. So we actually got it in here, and it says hello to you. We're doing it. We're clearing the data. We're letting it sleep. But what we might want to do is we might want to turn that backlight on and off. So we actually have the ability to do that. This thing here, you're going to find that LCDs within your helper files, and you may be wondering, well, how do I get to this? If you remember last week, I went and I actually showed you the read the docs for CircuitPython is the area where you can get lots of information, and there's lots of links again in Learn Guides as well. In Arduino, it's a little bit harder. You actually have to get in and either find a good example that explains it to you, or you have to go in and look at the helper file and read the helper file and try to figure out what's inside there or find out who wrote it, because lots of different people write helper files. So it depends on the language and how easy it is to find. Some examples are nice and clear, some not as much. Sometimes you have to search through 2 or 3 different ones. So what I'm going to do here is I'm going to actually go into here. When I tell it to clear the screen, after I'm finished the sleep, actually I want to turn the screen off. So I'm going to add another rung in here on between 17 and 18. Or 17 and 19, I'm going to add in rung 18. And this time I'm going to tell it LCD, and I want to actually turn off the backlight. So I'm just going to use in here, I'm going to use in a function that they have in here called LCD backlight, .backlight, and I'm just going to make it equal to false. And when I do that, it's going to turn the light out. So one thing I better do for when it goes through the loop here is I probably should come back up to the top here, and I should include LCD.backlight, and I should make sure that the screen is on when I first start. So there we are there. So now I've set it to true here, and I've set it to false there. If I save this, it's going to go onto my screen, so we'll be able to see it down there in the bottom left. Right away, I'm going to do it. It says hello to you right now. After 5 seconds, we're going to see the screen went dark. It's going to save me power if I'm running on a battery when I don't need to display a message. And yet it turns the screen back on when I'm ready. So I can actually have that screen on and off as I need it on and off. Now you can see my little camera is trying to search for focus because it keeps changing on the screen, but it shouldn't be too distracting. And it's actually giving us an example of how to turn the backlight on and off. Pretty simple. Now, there are lots of other functions in here. Trust me, there are a ton of functions in here. So what we can do in here is we can actually turn around and we can actually load up a bunch of other functions in here. Now, I'm going to show you how to do a little bit of that, but I don't want to get too involved because we are going to have to take some time to come back in here and basically have time to work with the Arduino. We want to make sure we do that. So something that we can do in here, I can go hello world, hello to you. I'm going to add some new code in here, and I'm going to put in the LCD clear again because I want to clear the screen. Oh, I better put my brackets in. So that's going to clear the screen, but then I'm going to write a new LCD message, and I'm going to show you a different way of writing the message now. So what I can do here is I can say hello message equals, and this time what I'm going to do is I'm going to say, I'm just going to put in here my first line, and then what I want to do is I want to drop down to the next line. So I can put in a forward slash. I think that's a forward slash, backslash, whichever slash that is. That's probably backslash. N, small n, which tells me it's next line. So what happens here is this character, the slash mark, says I'm going to put in a command in the middle of my text statement. And my command is N, which is next row. So basically what it's going to do, it's going to go from row 1 down to row 2. Or in reality, they actually call it from first row to second row, which is actually row 0 to row 1. Everything starts with 0 in most computer languages. And then I'm going to add in here, and I'm just going to type in the. I shouldn't need a space in there, and it's the second line. So what I've done there is I've actually added that in. I need to put the quote at the end of it. If I save that, we should see that happen on there. Although that's going to happen right away. I need to put in a small delay here afterwards. So I'm just going to type in here time dot sleep, and I'm going to put in a delay of, well, we're using 5 seconds, so let's continue with 5 seconds for the moment. So what I've got now is it's going to say hello to you, like it's been doing and still doing down there on the left hand edge of the screen. It's going to clear the screen, and then it's going to say my first line, and then it's going to jump down to the second line and say the second line. And then it's going to wait 5 seconds. It's going to turn off the backlight. It's going to clear the display, and it gets to start over again. So let's see if that works. I'm going to go ahead and do that. It says hello to you. And after 5 seconds, there it is, my first line, the second line. So we actually got that up there. The screen went blank. And then we're going to come back up to the top of the loop, and we're going to say hello to you, and we're going to go back to my first line, my second line. Pretty simple. Pretty simple. Now, what I'm going to do is I'm going to cheat a little bit here. I'm going to copy a little bit of code so I have time to run the Arduino examples, because we want to do that. And what I'm going to do here is I'm going to copy some code that I had pre-written that shows more examples of what goes on. So I'm just going to copy that. I'm going to come over here. I'm going to highlight this area, and I'm going to replace all this code now with a whole bunch more code. See, I didn't want to have to spend all the time typing all this. And that's not important. These are out of examples, put into range, or put into different files. So let's give this, and we're going to save this, and we're going to see what happens. And this should work fine. So hello CircuitPython. There's our new message. And then we can write it backwards. You can do that. We can actually place the cursor on the page. You can see the underscore line there. We can make the cursor blink. So I'm just trying to describe these things as it's going through. Now I'm going to scroll to the left, and I'm going to scroll off the page, and it says going to sleep, see you later. And basically this is where we turn off the screen, and then when we come back we start the whole thing again. Hello CircuitPython. So we've added a few extra features in there, and I scrolled from the right to the left, which means we pushed it left. You can scroll from the left to the right. You can also position yourself anywhere you want on the page, so it doesn't have to be starting at the top left. You can pick any spot you want to start. There are lots and lots and lots of choices here. So hopefully that was interesting. I'm not going to go into all the detail on this code. If you want, you can send me a message through YouTube by all means. I will send you a copy of this code if you really want it. It's pretty simple, pretty straightforward, and it works. Now, to finish this off, what I would normally do is I would do what I've done here, is I've added all my comments in here. So I've actually put in here 5-second pause, reset the direction. So that's direction left to right, right to left. Display the cursor, 5-second pause, make the cursor blink, stop blinking cursor. I've added in all these comments. That comes in. Well, why did I do this? Why did I do that? This just lets me do it so I know what's going on. I don't want to have to figure it out later. Good habit to get into. I didn't do it up here at the top. In my real files, I would include more information at the top. I would probably put in what version of CircuitPython I'm currently using, since it does change, and they still are developing it. It changes more often than Arduino does. I might put in here that this is to set up all the configuration for the LCD screen. I would put a note in here maybe to change this for the size of LCD you're using. And I would probably put in here under I squared C that this one works with the Feather M4 Express, because if I were to use this on a couple of the other boards, a couple of the other smaller boards, it actually wouldn't work with the same address. You have to do it slightly differently. And that's fine. And that's just a difference between one board to another. Most of the boards in CircuitPython use this. Some of the other ones that have very limited memory, sometimes you got to use the other memory allocations as the way they're supplied from the manufacturer, because they just don't have the extra room to work with the memory. So that's it. And I hope that answers that. Please send me code. Neat stuff. Well, this isn't CircuitPython. You might want to wait. I don't know. I think you're using Arduino right now, Walter. So let's have a look at the Arduino version. So that was all about CircuitPython. So now what we're going to do is we're going to create something similar but set up for Arduino. So let me just change my screens out here. So I'm going to turn off this screen here. I think I turned this one on. There's my Arduino screen. And let me move this board out of the way. And let me bring the Arduino one in. This is a little bigger board. And I don't think we need to see the Arduino board itself too much. All the wires are connected on one side on this one. This is just your standard Arduino Uno. I'm not quite sure why there's nothing displaying there right now. It's not happy. Oh, just because you moved it. These are susceptible to electronic noise. So sometimes things will work, but that's okay. We're going to build a new file, and we're going to dump a file into it anyway, so it doesn't matter. We're going to be overwriting anything that's on that board. So this is our LCD screen that we're going to be writing to. Basically, I have my 5 volts and my ground connected here to 5 volts and ground pins. And again, there's the problem. Oh, one of my wires is loose. If I hit reset, it'll probably... oh yeah, it says there it's got a whole bunch of writing, because there is a program inside of it right now. So basically what we're going to do is we're going to recreate this program. So what we have here is it actually puts in the numbers, and then it puts the numbers on the second line, pushes them in the other direction, and you can see that it just goes through and does this kind of thing. So we're going to walk through a couple of steps here, because I want to show you how to build this in this case. So over here on my coding page, we can see that we just have a default page. This has not been saved yet. So the first thing I'm going to do is I'm going to go here and I'm going to hit File, Save As. And I'm going to save this file and I'm going to give it a name. So I want to go to my PC. I want to go to my documents, and I've got my electronic shows. I got a folder here called LCD for episode 7, but I have no sketches in here right now. So we're just going to call this LCD test. Nice, simple. Give it a nice, simple name, and I'm going to hit save. So there we go. So now we have one called LCD test up here. And then what I'm going to do is we're not going to be using everything in here, but we are going to start at the top. So let's just get a couple of extra lines here at the top, and let's start getting our typing in here. So this is, I'm just going to start with a title again. Testing a display. And I'm going to throw this in here. So I'm just going to do that. So I've actually created that in there. So now what we have to do is we have to put in those helper files. And remember I said I like to put comments in. I'll add them later. But we're going to actually have to include a helper file. So let me show you what's going on with this. And I hope I got enough room. I may have to shuffle my page around a little bit. Under Sketch here, what we need to do is we need to include a library. Now, chances are you are not going to have I2C the first time you're doing this. So you're going to have to go up and you're going to have to hit a managed library. And when you do that, you get another page up that looks like this. And what I would type in here is I'm going to type in here, let's see, this would be, and they actually use the long name in the helper file. So I'm going to go liquid, and I'm going to go, and there we go. We got some choices right off the bat. We got one called Liquid Crystal. And this is here built-in Arduino Adafruit version 1. Previously installed this. If you haven't installed this helper file, you would come down here and you would click on it and you would install it. In fact, this one here is called Adafruit Liquid Crystal. If I'm using their backpack, the one I showed you the first time, let me just flip this over for a moment. This is a backpack off of eBay. This is cheaper than Adafruit's, and it plugs in the same way. I actually put a header pin on it. Normally you just solder them directly on, and it has a pot in the back, a variable resistor to set the contrast. Now I've already done that ahead of time, and I've basically set that all up. So I've done that ahead of time, but once wiring is exactly the same, it's just the communications is different and you have to use the proper libraries. If I was using the Arduino backpack, this one now works here, and actually for this little tiny one now with support for ATtiny85. That might interest Brian. You can actually run an LCD screen on using an Tiny 85 and behind. Brian likes these little chips, and they are neat. These are tiny little chips that can run in the background. So it actually gives you the possibility to put screens on with very tiny processors. And then there's other ones here that all mention liquid crystal display, LCD keypad, async. Now, like I said, there's lots of files out there. There's lots of people who make stuff like this. So you might want to, if you're not sure whose. I've already done this ahead of time. Liquid crystal was the one that I used. This allows me to use it. It's based on a certain chipset. Everything's fine. It's happy. So it's here. So what I'm going to do now is I'm going to go down here to my sketch. I'm going to go to add, include library, and just off your page down here at the bottom, let me actually bring that up a little bit so I can see it. Now you're going to lose the sketch button at the top, but include library. I'm going to come way down here, and it's still off the page. Wow, that's a long way down. Let's see if this has got enough room now. As you can see, my list of libraries are getting longer. There is one here called Liquid Crystal. That works if you're not using the backboard and connecting 8-pin connections. The 6 plus the 2 for power. Way down here, because I'm using an I2C backpack, I have to include that library. So when I do, it puts it up here for me. And I'm going to come down here and I'm going to bring this back down onto my page so you can see it. It put it at the top above my comments. I don't want it there. I'm just going to strictly cut it out of there and put it down here where I want it. Now, because this isn't a problem up here because I don't only have comments above it. Include files have to be the first thing that actually execute in the program in Arduino. So they have to be at the top. But you can add comments ahead of them. You just can't put anything else that's going to be loaded in to the microprocessor ahead of includes. So again, what we're going to do under here is we're going to do a couple of things here. I'm going to set up an integer because I have to specify the data type for Arduino. And I'm going to put in here, and I'm going to go integer, and I'm going to put in my columns equal to 16. And don't forget in Arduino to include that semicolon at the end. I'm also going to go in here, and I'm going to go my number of rows, and I'm just going to go rows equals 2. So now I've got it, and I've set those up. Now what I have to do is similar to what I do before. By including the file liquid underscore I2C.h in there, that file, that helper file, it's already created the actual I2C bus for me because it's part of the built-in Arduino. It's already addressed it and told me how to use it. What I have to do now is I have to set up the actual liquid crystal display. So I'm going to do that. I'm going to go here to, and just like it did in CircuitPython, when you're using something, you probably end up using the helper name at some point. So liquid crystal underscore I2C, and you can see it changed to that orangey color because it matches what I have there. I'm going to go space. I'm going to call it LCD. I called it LCD in the last one. I'm going to call it LCD in this one as well. And then what we have here is we're going to say LCD. We're going to put it in the bracket. Now, just like I did before, I had to put in parameters to set up the LCD. I do in this one too, but instead of just calling it I2C, because I'm just attached to the board and it connects automatically, what I need to do is I need to load the address of the module in there. And I happen to know from the manufacturer information that this was 0x3f. And the 0x just tells me it's a hexadecimal number. And then what I want to add is the number of columns and the number of rows. So that part's the, forget the semicolon at the end. So everything there is basically what I had to do at the top of the CircuitPython. It was a little longer in CircuitPython because it only loads in the modules that I needed, whereas Arduino preloads in a lot of modules for you. So that's why it looks a little shorter, because it's only one specific for the LCD that I needed to load, where I had to load everything in the other one. Now we can go into the setup. So I'm going to get rid of this comment in here because we're not going to put comments in to start with. And I have to initialize this LCD. Now I did this before the loop in CircuitPython. In here I need to do it in the setup because it has. I'm just going to create lcd.initiate, which looks just like that. So this one tells it to turn on the LCD. Then I'm going to do a couple of other things in here if I need to. If anything else, the one thing I do like to put in here so it doesn't take off on me right away is I want to add a delay of about 1 second. And that's just to give me a pause before I get into the program. So now let's get into the loop, because what we want to do is we want to create something similar to what we did in the other code. Now in the other code, I started it and I had to do something. Oh, there's one. Got it highlighted. I initiated the display. The other thing I probably want to do is I want to do lcd.clear. That's actually the same command as what it was in the other one. And that just gets rid of anything that's previously on the page, on the screen. So that way it just clears it off. It gives you a clean slate to start with. So that's what I've done there, and I've done everything else here. Now, we can turn on the display, we can turn off the display. We'll see if we need to come back and turn that on or not. But for now, we're going to go jump down here to the loop. And what I want to do is I want to tell it to write a message. So we're going to say if this works or not. So I'm just going to tell it to go LCD, and instead of message, this particular one uses the word print. So it just says LCD print, and then basically I'm going to go in here, I'm going to go in there, I'm going to put in a set of quotes, and let me change that to a capital H because I like capitals in there. Hello to you. That's what I wrote in the other one, so let's do it in here. We're going to put in a delay of 5 seconds. That'll seem like forever. Now, something I need up here. Got to remember to put my semicolons in when I'm typing in Arduino. Okay, so what I'm going to do there, and then what I want to do here is I want to do an LCD clear. And then I'm going to add another delay. And this is very similar to what. So I've come down here, I've set up my screen, I've told it to initiate to clear, delay it for 1 second, and then I come in and I say hello to you. I clear it and I go back here, and then it's going to repeat, and we're going to see what happens when we do this. So I'm going to go ahead and I'm going to do my tools down here. I got to make sure I'm connected to my COM port, and it says that's the Arduino Uno. It's recognizing that. So we're going to go ahead and that because I upload that because I think it's should be okay. I think I got my code right. Oh, it did not. And I can't type. That should be COLS, not CLOS. Isn't that smart? It actually told me that I had an error there. But that's okay. We fix it. And when we do that, it's uploading it. There, my screen blanked out. Now, look at that. My screen stayed dark. Unlike CircuitPython, the library I use there, the library I use here doesn't turn on the backlight. So we're going to have to go in and turn this on. So let's turn around and let's make a change to our code here. Let's go and we'll set this up. We can set this up in the original here. So what I'm going to do here is I'm just going to move in here and I'm going to put LCD dot. And again, they call it backlight just like it was in the other one. And I'm just going to do that because that will set it to true. And that will turn on the backlight. So now that we've done that, we're going to go ahead and upload that. But you can see how dark that screen is. The text was still going by. It just wasn't working. Yeah. So now it says hello to you, and it clears the screen. And when it prints it back up, where does it go? Let's have a look. Oh, and went right back up to the top corner. So every time I give it a new message, right now it's going to start at 0, 0, which is really good. It's going to start in the position that I wanted it to. So that worked. So that worked really, really well, and without too much problem. So I'm going to go in here, and we're going to create a little extra code in here. So what I wanted to do in the other one is when I turned it off, I turned off the backlight. Now, do I have the backlight? I think it's just, I got to remember what it is because I actually don't have this one in my notes. We're going to see if it likes it or not. So what I'm going to do is here, I'm going to go here, and I'm going to go LCD dot no. And that's not it. So let's just put in backlight again. And we're going to see if that does it. I can't remember if that's the one that does it or not. But what I'm going to have to do in here for sure is I'm going to have to go LCD dot backlight to make sure it turns back on. I haven't turned off the screen in a while, so we're going to see if this works or not. I don't know if it will or not. Let me do a validate on it before we try to upload it. No matching function, liquid crystal backlight. All right, so that doesn't like the 0. What we might be able to do is we might be able to add the false in here. That might be a small f. There we go. It just changed to a different color. Differences in languages here. Nope. It doesn't like that. So backlight is not set to false. How do we turn the backlight off? Anybody remember how? Right offhand? I don't remember how to turn that off. And I thought I had that in this particular one, but I don't. You can see that when I did it with CircuitPython, all I had to do was set the backlight to true or false to turn it on or off. In this case here, it ran that function. And I'm going to try one. And that's not a keyword. Backlight off. Nope. So I would have to go back into that helper file and figure that out. But in the meantime, we can just leave that backlight on. It'll stay on for now. So let me get rid of that lines of code, because we will show you something else instead, because I don't need to do that now. What we're going to do is we're going to do something simple in here. We've done the clear. We can validate that again because I want to get rid of the orange line. Brian hasn't answered me back. He's done a few LCD screens, but he doesn't remember what it is either, I don't think. So what we can do here is we can set something here, and what I can do is I've gone here, and then what I'm going to do is I'm going to change the position of my cursor. So after this 5-second delay, I'm going to change the position of the cursor. So I can go LCD, and they have a function called set cursor. Oh, it's a small s in set, not capital. Set cursor, and then you give it a position, and you give it a position of a column row. So what I'm going to do is I'm actually going to move it down to the next line. So I'm going to start with column 0, but I'm going to move to row 1 this time. And then what I can do is I can do an LCD.print look, more text. So I've actually been able to do that in here. And we're going to have to add in a delay. Otherwise, it's going to turn it off right away because we hit that clear right away, and we don't want to do that. So basically what I've got in here, it's going to say hello to you, then it's going to move down to the next line, it's going to say look more text, and then it's going to clear it, and then it should start over. If I did it right. So we're going to see what happens on the display. There it is. It just shut off. It's rebooting. Hello to you. And after 5 seconds, we should see the second line come up. Look at that. Look more text. So we're able to position to that one just fine. And then we can clear it, and then it's going to keep repeating. Another function that we can have in here, we can actually get it into things like auto scrolling. So there is things that we can do with that, and we can have it display the numbers. Remember when it came up at the beginning, it was auto scrolling to the right, then scrolling to the left. Basically, the way that code looks, I'm just going to copy some code in here just to show you what that looks like. I'm going to copy it. I'm going to come down here and I'm going to put it after this delay. I'm going to fill in some code. So this is the structure here. LCD cursor 0, 0. I'm going to position the cursor back to the home position. You can also use the word home if you're going to position 0, 0. So instead of saying this, I could actually do, and I'll show you this here because I'll show you that it works. I can use the word home. Home knows to go to the position 0, 0. This one here, I want to go to the second line. So it's going to go to column 16, position 1, which is way over on the right-hand side, and then it's going to scroll back into the page. So let's see how this works. I'm going to compile it. And when we look down at the screen, we should be able to see that come up. There it is, hello to you. Look, more text. And we're going to clear that. And after 5 seconds, it's going to go into this next part of the function that it has. And there it is. It's adding the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it adds it in from the right-hand side and scrolls left. So you can turn on the auto scroll. See where my text started out? Look how messed up that gets. Why? Because I didn't give the first one a position and I'm not in that spot when I finished. So I'm going to go up here and we're going to add one more lcd.home just to make sure that it gets back to the start where we wanted it. And probably what we want to do is after all of this, at the end, we probably want to include an lcd.clear to get rid of any text that was there. And let's see the difference that we get this time. So it's uploading. Here's our display. It now says hello to you. It should come down, look more text. That's the part I added. Now it should clear and we should start getting our numbers if everything's working right. And there they come. Now we're getting the numbers. We'll get the numbers in the reverse direction. And this is how it works. Now it's cleared and back up at the top. Whoa, why did it go way over there? It didn't like home. Normally home works fine. This is why we experiment. Different ones have different features. So I'm going to go here 0, 0. I'm going to go ahead and pick that spot mechanically right in my file. I'm going to just check that. It's happy. So home was a valid function. It just didn't work the way I wanted it to. I'm not sure why, but it should have worked. But I'm going to set cursor at the top. Let's run through the example again. These are the things that happen all the time in it, and we spend a lot of times just getting it all defined. Yeah, no easy way to turn it off. That's what Brian says here for the LCD. There is a way to do it, and it depends on it. I'd have to get in and dig into the code. We don't have time for that today. But let's see what happens here. Now, what's going to happen with my numbers finish? It should come back up to the first spot it's still staying over there, so something still is not happy. And I'm not sure why, because the auto scroll. Hold on, what did we have here in the code here? Turn on auto scroll. Where did we turn it off? Oh, you know what? We never turned off the auto scroll. That's our problem. I'm going to grab a line from here so I don't have to do it. What I want to do is, before I clear this data, no auto scroll. That's why I was thinking it was no. Oh, you know what? It might be no backlight with a capital B. I'm going to try that in a moment. But anyways, let's just do this. Let's get our positioning correct. Let's take a moment to do this. Oh, I missed the L in LCD when I was copying. There we go. We'll run this again. Now it's uploading. Let's give this a test. It's only going to take a few seconds to try it all. So hello to you. And then we should get the second line. We get more text. Good. Numbers. Let us put the numbers back in the other direction when we're done here. Hopefully we'll clear and we'll be back up at the top and we'll, oh, look at that. It went back to the proper spot this time. Whew. Lucky for me. No auto scroll. So let me try something here. I'm just going to throw it in here, and I'm going to go in here and I'm going to throw an LCD dot no. That's the key word. It shows it up there. Which means after the delay, I'm going to have to turn it back on, which is going to be LCD dot backlight. And that should turn it back on, but we'll get 5 seconds of it off after it says looks no more text. One more try. So we might be okay here. See that? We're learning. We're learning as we go. So here's the initial load. Hello to you. Now we should get the LCD should turn off if it's working right. It did. So that's how we turn it off in this particular, with this helper file, and then back on. So we did figure it out. Look at that. We actually took a few moments, figured it out. It now says, so now we can do it. We're going to roll over. When we finish this, we cleared it and we went back to the beginning. So there we go. So there's another block of code, and that has been saved. I can send you that if you want that one as well. And this is the Arduino version. So there you go. So this is how we create and use an LCD screen display, a simple LCD, which are common screens out there. There's lots of LCDs. There are cheaper ones. LCDs are not necessarily the cheapest. Hooking up the backplane will save you a lot of hassle. Using one of the I2C backplanes, whether you're using it on CircuitPython or whether you're using it with Arduino, doesn't really matter. You should use one of the backplanes. Yeah, back to home. Yeah, I'm not sure there, Brian, but we're gonna see. And home might work again at the top because I do have it down further. Interchangeable. That set cursor to 0, 0 or home should be the same command. I think it's something you can play with. I don't know. We've been here for about an hour now. We probably don't want to go too much further on this right now, but you're welcome to give this a try. Let me know if you want any of this coding. I can send you these 2 files. I have these saved. That's not a problem, and I will gladly send it to you, and you can add your own stuff to it. You can make changes to it. You can play around, but it's a place to get started. And that's the key, is to get started. Get yourself built up. Try it out and see how it works, and then look for more examples that show you more code. And there are always more examples out there. Lots of people have written things for LCDs over the years. They're very common. So anyways, thank you very much. Thanks for watching the stream. I see I have Brian, thank you. Walter, thank you. There's somebody else who hasn't mentioned themselves, but thank you for leave it here because next week we're going to have a new topic. I'm not sure what the topic's going to be next week. So make sure when we're doing this that you follow me on Twitter if you use Twitter. Follow me at kingernorth. That makes it easy. I send out tweets the day before and just slightly before the show. Also, you can subscribe to YouTube and subscribe to my channel at youtube.com/kingernorth, which is where you're watching this right now. Be sure to subscribe. Can't wait to try. Yeah, you might need that backpack. I don't know if you have one of those backpacks or not. If not, you can wire it up with all the extra wires like I showed in that other picture, and you can still write the code. You just don't need to do the I2C connections. So you can go ahead and do that. There's lots of examples for that too. This was episode 7 of Microcontrollers with kingernorth. This was connecting an LCD display with CircuitPython and Arduino, and I hope you enjoyed it. Thanks for watching.